Hello guys, today we are going to discuss the chapter 3 motion in a straight line. Okay, first of all, it's an easy chapter because in the case of 11th standard there are 14 physics chapters. In that 14 chapters, the 3 and 4 chapters, first 3 and 4 chapters are very simple according to the remaining chapters. So you want to sense that and you want to think the upcoming chapters are very difficult. So try to understand the whole topic in this chapter so we can go directly into the class. What is motion in a straight line? Motion in a straight line. When we heard the heading motion in a straight line, it is a motion only in a straight line. Suppose just a movement of train having no deviations or no turns. Okay, that type of motion. Or car is moving in a straight road. It is not moving to left or right little bit, moving only in a straight line. That type of motion is called straight line. And define what is instantaneous velocity. Okay, we all know about the Instagram. What is Instagram? It is an instant messaging app. Okay, instant messaging app. In that sense, we can say that instantaneous velocity is a velocity that's saying about the velocity at that instant, at that particular moment or that instant. You just click your hands at it is only a little bit fraction of second. That seconds. Okay, instant second is called instantaneous velocity. Velocity, we can go to the explanation. The velocity of at an instant is called instantaneous velocity. Equation: v is the velocity. V is equal to limit delta t tends to 0. What is delta t? Delta t means change in the time. When the change in time is approximately equal to 0. The change in time means if you just check the time at the time of 10 minutes or 5 o'clock and you just check a particular type of measurement after 1 hour means 11. The difference is 11 am and 10 am. T2 minus T1 here is 11 am and 10 am. So 11 am and 10 am means the difference of 1 hour. So delta t means 1 hour. So in here delta t is an arrow mark. It means tends to 0. Delta is going to 0. The value of 0. That means the change in delta is very small. That is meaning of that. The change in delta is very small. So delta t tends to 0 means the change in the time. That means T2 minus T1 is 0 means for example we can take 3 am. Okay, T1 means 3 am. T2 is 3 and 1 minute. 3 and 1 minute or 3 and 30 seconds. So the difference is 3 and 30 seconds minus 3 am. So the difference 30 seconds. So we can say it is approximately or it is reaching to 0. It is not a big value. 30 seconds is not a big value when compared to minutes or hours. So we'll spend a lot of time for that concept because these types of small concepts want to grasp at the time when we start to study. This is your beginning of your +1. So I believe I also taking classes in 10th standard. We don't hear or heard that these types of topic at 10. So this is another universe for the students. This is another universe. +1 and +2 is another universe, and you can think that 10th is another universe. 10th is very simple because the things are all continuation because 8th standard is continuation of 7th standard and 9th standard is a continuation of 8th standard and 10th standard is a continuation of 9th standard, but we can't see the continuation. We can only see a small continuation from the 10th standard. We are entirely studying a big topic on 11th standard. So when does the average velocity become equal to instantaneous velocity? Next question, we want to know how we can find average velocity. what is average velocity and instantaneous velocity. You don't want to, average velocity means if a body started from A, traveling from A, and it travel 10 kilometer and it reaches B. So the average velocity is the total velocity or the average or mean velocity in the whole traveling. But instantaneous velocity is the velocity at that instant. Sometimes the anywhere on the way at the particular moment's velocity is instantaneous velocity. And we want to know how we can write these expressions. Limit when time interval delta t tends to 0, the average velocity become equal to instantaneous velocity. The way the average velocity, when we give the limit delta t tends to 0, the average velocity will become instantaneous velocity. Okay, when the average velocity we give the limit delta t tends to 0, it become instantaneous velocity. So we want to remind that when we write the expression of average velocity, it is indicate using delta as a symbol like triangle, but when we write the instantaneous velocity, we use d by d. Okay, the speedometer of vehicle shows the instantaneous speed. We get define uniform motion. If an object moving along the straight line covers equal distance in equal interval of time. What is saying? If an object is moving, suppose you think an object is moving, and the object is covering equal distance in equal interval of time. Suppose a car or bike or any other type of vehicle, it is traveling and it's keeping a discipline. For example, you also know that you have all people are going classes and you have periods having 40 minutes. Every 40 minutes you all hear the ringing of the bell. So it has a periodicity. As like that, if a car is moving 10 kilometer with 5 minutes and another 5 minutes the car is moving correct 10 minutes and another 10 minutes the car is moving 10 minutes. This types of motion is called uniform motion. Okay, if an object moving along a straight line, if an object is moving in a straight line, you also want to think that object want to move in a straight line. Okay, straight line. Without going in straight line, it does not happen, because when we taking the turns, there is chance for the unequal motion, and so this types of motion is called uniform motion. Again, I am just going through the definition. If an object moving along a straight line covers equal distance in equal interval of time, equal distance in equal time gap, is called uniform motion. Draw the position time graph of an object moving with uniform velocity, uniform negative velocity, and at rest. We are going to draw 3 graphs. On the x-axis, we are showing or we are representing the time, and on the y-axis, we are representing the position. So this types of graph is called position time graph. How can we draw a position time graph? When we draw the position time graph, we want to listen that or remind that position, it is coming first. So first coming thing want to plot on the y-axis, and time want to plot on the x-axis. So position time graph is equal to y-x graph. Okay, so we just plot the position on the y-axis and time on the y-axis, and for uniform positive velocity, we want to draw a graph inclined in between x-axis and y-axis. Okay, inclined graph, a slope, or equally inclined graph having 45 degree. Okay, in between 90 degree, we want to draw a slope. This graph indicate the uniform positive velocity. And what indicate uniform? The next graph indicate uniform negative velocity. We want to draw a slope as like in the figure, and want to plot position on the y-axis and time on the x-axis. And third graph shows the object at rest. So you just think that time is going on the x-axis, but the y-axis position is constant. It indicates the object at rest. The position time graph of an object in uniform motion is straight line inclined to time axis. So the position time graph of an object in uniform motion. What indicate the uniform motion? Uniform motion graph. That we said the position time graph of an object in uniform motion. It is a line, okay, in between the x-axis and y-axis, okay, in between the middle of the x-axis and y-axis, inclined line. The slope of a position time graph gives velocity. You want to understand that when we draw a position time graph, we get an inclined line, okay, or any line. If we take that line's slope, we get velocity. So slope of the position time graph gives velocity, okay. And the velocity time graph of an object in uniform motion is straight line parallel to the time axis. The velocity time graph of an object, when we draw a graph of velocity time, that means velocity want to be on the y-axis and time on the x-axis. If it is a uniform motion, we get a straight line that is parallel to the x-axis. That line must be parallel to the x-axis. So the 8th question, and the graph is uniform motion. And the area under velocity time graph gives displacement. If we draw a velocity time graph and we get a line that may be slope or any types of straight lines or line parallel to the x-axis or whatever it may be, but the area under that line indicates the displacement. Suppose here in this figure there is a line that is parallel to the y-axis, and take the area under that line. So we get an imaginary rectangle. If we find the area of that imaginary rectangle, we get displacement, that is area under the slope or the line, we get displacement. Suppose it may be a trapezium or a square. It's an imaginary square or imaginary trapezium. We want to find the area of that geometry, and that area will give the displacement. 10th question, the slope of velocity time graph gives acceleration. If we draw a graph of velocity on the y-axis and time on the x-axis, we find the slope, it will give acceleration, that we have already said. Define average acceleration. What is average acceleration? The average acceleration over a time interval is defined as a ratio of change in velocity to the time interval. That means it is an ratio. It is a division or a ratio or a comparison with the velocity or the change in velocity to the change in time or time interval. When we look the equation, acceleration, it is an vector quantity, so we put an n cap over a, and the equation is change in velocity by change in time, or change in velocity by change in or time interval. So we can write it as delta v by delta t. Draw 12th question. Draw the position time graph of an object moving with positive acceleration, negative acceleration, and zero acceleration. How can we draw the graph? First of all, just draw the x-axis and y-axis, and we need a line little bit inclined, little bit curved, okay. It give positive acceleration, and want to curve inwards, it gives negative acceleration, and a straight line between x-axis and y-axis, it indicate the zero acceleration. You can check the figure and want to keep in mind the questions are getting frequent about the graph, so beware. What is the 13th question? Draw the velocity time graph of an object moving with uniform positive acceleration and uniform negative acceleration. You just look the graph. Velocity is plotting on the y-axis, and time on the y-axis. Before starting the graph, we want to just give a gap on the y-axis, because it means the car or no any object can be in uniform or in a steady motion at the time of starting. Suppose if a car is getting in uniform motion, first of all it just on and want to move a little. After some times only that car is getting uniform motion. Am I right? Yes. So it indicates that. So getting in a uniform motion or in a steady motion, it need a little time before starting, after starting. It is the reason for the gap in the y-axis. You all think that why is this line or a straight line, in straight inclined line, not start from the origin? Okay. So at every time you want to keep in mind that don't want to start from the origin, just give a little gap on the y-axis and start the inclined line. And it represents the uniform positive motion and uniform negative acceleration. It is a downward inclined line starting from the y-axis. Draw the velocity time graph of a stone thrown vertically upwards and come back. You just think, if you thrown a stone upwards, the acceleration first increases and it gets zero, and after that it comes back to the earth. At that time that acceleration is in negative, so the graph will go to the negative words or downwards. So the graph will be like that. You want to strictly observe. You just think, first of all the acceleration will increase, and at a little time the acceleration increase, and after that acceleration getting zero and acceleration getting decrease, and it reaches zero, and the stone or the ball will come back to the earth. At that time the acceleration will be negative, so that's why the graph go to downwards or negative side. Fifth question, draw the speed time graph of a stone thrown vertically upwards and comebacks. Here we are drawing not the acceleration time, we are drawing the speed time graph. So speed cannot become negative, so at the time when we thrown, it has high speed, and after time goes the speed will reach zero at the top and speed will again increase. Okay, but when we draw the acceleration time, the speed is not like acceleration is getting negative. That's why the graph go to downwards or negative side. Here when we draw the speed time graph, the graph not want to go to the negative direction. We want to join the line at x-axis, that indicate the speed is getting zero. And it is a tricky question. Question is, if there is no velocity, is there is any chance for the value of acceleration? Once again, if there is no velocity, there is no value of velocity, that means velocity is zero. Is there any chance to get a acceleration, to get an acceleration having non-zero value? Yes. When we thrown a stone upwards and it reaches at the top, at that time for a moment the stone will be in zero velocity at its highest peak. At that time the stone have acceleration, only acceleration, but at that time velocity will be zero. So it's a good example, having zero velocity but non-zero acceleration. Okay. 18th question, velocity time graph of a ball thrown vertically upwards with an initial velocity is shown figure. It is an figure, that's a stone thrown upwards having initial velocity 100 and the velocity is decreasing by time, and it reaches 10 and the velocity is getting negative. We can look a question, what is the magnitude of initial velocity of the ball? We all know that the graph is starting from the 100, so the initial velocity we can take it as 100 meter per second. Calculate the distance traveled by the ball during 20 seconds from the graph. We want to calculate the distance traveled by the ball. That means distance travel. We have already studied that at the time of when we draw a velocity time graph, how can we find displacement? the area under the graph is the displacement. So first one, we want to take the first line as AB. AB, the area under AB is like a triangle, and we want to take the another line, half of the line or next part of the line BD, and we want to take the under the area of BD. It is also a triangle called BDC. So here we have two triangle. If we find the area of that two triangle and we add the area, we get the displacement. Okay, so we are going to find the areas of the triangle BAO and BDC. So we put half BH and we substitute the values. Half B1, the value of B1 is 10. That means base from 0 to 10 of the first triangle, and H is 0 to 100, that means 100, plus half into, again B2 is also 10 and B1 is also 100. We put the values and we get the value 1,000 meter. So the displacement or the area of the two triangles is 1,000 meter. So that area is the displacement. It means 1,000 meter is the displacement. Okay. How third question, what is the acceleration? How can we find the acceleration? To find the acceleration, we want to find the slope. That means V2 minus V1 and T2 minus T1. Here we know the V2 and V1. Substitute the values 0 and 100 and 10 minus 0. We get minus 10 meter per second. So this is the acceleration. We can continue the remaining part on the next session. Thank you.